A quick report on some physics shenanigans. Here we have a circumstance where a one mass hits a two mass. The one mass has, say, 100 momentum. The two mass will leave with 130. It's clearly free energy being created because it's free momentum. So the reveal, quickly.
You ready?
Yeah, do it. I only got a minute.
Yeah.
Now, hurry up.
There we go.
Come on, do it. Jeez. All right. So it's three quarters. Instead of it coming out half the speed, the twice as heavy object should be half the speed to conserve energy. It's not half the speed. It's three quarters, 2/3. I mean, and therefore it has 130 momentum. It's a third more momentum than what went in that direction. So we collect energy in a direction. It's free energy. It's a paradox. It's not explained. There's something wrong here. Somebody should have an answer.
Oh, all I can really derive in terms of the quantum mechanics is it doesn't have to be a perfect answer. And obviously, the drive to I don't want to say simulate, but theorize, I would say, would lie in trying to practice physics. And so real, the only real answer that I think that I can get that is a little bit profound or extraordinary is just that when the little mass hits the little mass hitting the big mass, the little mass, uh, would deflect slower, and when the big mass moving slower hits the little mass would move faster. So obviously, the little mass in terms of the equation, uh, one half mv squared. So when the little mass is hitting the big mass, uh, it moves at a very slow speed, and the big mass can be not moving or moving at very slow speed, but still the deflection is going to be very slow. So when the big mass, in terms of the inverse, the big mass is going to hit the little mass, and the little mass is going to shoot off. The real uh, paradox or the equation that I would see is a big mass is a bigger clump or hitting the smaller mass, and the smaller mass uh, being shot faster. Um, so it could explain an orbital such as the sun. You have the sun and you have the earth, and the earth moves around the sun at a quicker rate. The sun moves around earth. If this sun would ever move around earth, that is to say, and the moon also moves around earth faster than the earth would ever move around uh, the moon. And again, that is the paradoxal showing, because it's the big mass, again, a big mass moving very slowly, hitting a very small mass, and sending the very small mass at an extremely high rate of speed. So my sense of it is that it is a detection of gravity. It is a detection of a just gravity. Just in the three body problem, the sun, the moon, and the earth. And it is, I mean, that's a clear correlation of how you can, there is an orbital effect as far as the actual uh, elliptical orbit that they both move around their bigger family objects. It just is a matter of something else. I mean, it doesn't have to be. It doesn't really have to be necessarily uh, in terms of a free energy and the temperature and all of this, or the the Gibbs free energy. I don't think that that is like an exact. I mean, yeah, it might be a segment, but yeah, I suppose that. Well, let's do it one more time.
All right, a quick report on some physics shenanigans. Here we have a circumstance where a one mass hits a two mass. The one mass has, say, 100 momentum. The two mass will leave with 130. It's clearly free energy being created because it's free momentum. So the reveal, quickly.
You ready?
You do it. I only got a minute.
Yeah.
Now, hurry up.
There we go.
Come on, do it. Jeez. All right. So it's three quarters. Instead of it coming out half the speed, the twice as heavy object should be half the speed to conserve energy. It's not half the speed. It's three quarters, 2/3. I mean, and therefore it has 130 momentum. It's a third more momentum than what went in that direction. So we collect energy in a direction. It's free energy. It's a paradox. It's not explained. There's something wrong here. Somebody should have an answer.
Uh, just to go along, just in terms of uh, a solar system analogy. Again, uh, clearly, if you do the math and you find that the bigger mass is moving slower and it hits the smaller mass and the smaller mass moves uh, faster, that doesn't make any sense. But in terms of orbit and my only thought that might not have been explained uh, is that there might be a cause might lie in the deflection. So when the actual smaller mass hits the bigger mass and it deflects, then that smaller mass is causing just from the impact, a it causes the Gibbs free energy, and it causes the temperature, and so I'm just saying that the deflection and the collision and the the repulsion, the absolute repulsion could cause that extra energy, the Gibbs free energy, and then because if they're calculating the tracks that it was sitting on, and I mean, I'll just try to articulate it like you just have your smaller object going into your bigger object, and again inversely. So I mean, I'm just saying in terms of the moon, sorry, asteroid hitting the Earth. Uh, the asteroid hits the Earth the kinetic energy. Okay, the kinetic energy equation. As the asteroid hits the Earth at a high speed and deflects at a slower speed. In turn, the quantum gravity could enlarge. I mean, I don't. I mean, in turn, the Earth is going to pull it since it's in rotation, since it's in orbit with the Sun. Then the Earth may have enough gravitational force to uh, pull the Moon into its orbit. Since when again the smaller object is going to deflect, it's going to move slower. It can get into orbit, and instead of taking a direct repulsion like 100% horizontally out, it can get into the curvature or the gravitational axis of the bigger mass, because again the bigger mass is not moving, or it is moving at a slower rate in the same direction, and that deflection is not supposed to cause that spin. And so that could be the spin. So again, when there is that collision with the bigger mass, the smaller mass hits the bigger mass, and that collision could be equivocal to the spin, and then gaining an orbital from the gravity of the bigger mass. And so when you have yeah, when you have the again when you have the repulsion. Let me watch it.
A quick report on some physics shenanigans. Here we have a circumstance where a one mass hits a two mass. The one mass has, say, 100 momentum. The two mass will leave with 130. It's clearly free energy being created because it's free momentum. So the reveal, quickly.
You ready?
You do it. I only got a minute.
Yeah.
Now, hurry up.
There we go.
Come on, do it. Jeez. All right. So it's 3/4. Instead of it coming out half the speed, the twice as heavy object should be half the speed to conserve energy. It's not half the speed. It's 3/4, 2/3. I mean, and therefore it has 130 momentum. It's a third more momentum than what went in that direction. So
Again, I'm just trying to quantitate orbital spin effect. I'm just trying to qualify and to quantify a spin effect. So this the smaller so the smaller mass is going into the bigger mass, and when they collide, the smaller mass is spinning off at a slower rate, and that could be a compensation effect of the bigger mass. I mean, I'm just saying, if in terms of they are uh, they are using temperature in the experiment, or they are, because they are using. I would say it's arguable that they're using temperature, since there is a collision, and it could be colliding atoms. So yeah, again, the bigger mass is going to play off at a higher speed than you actually think it is, but the actual energy is going into uh, I should say the smaller mass. If that makes sense, since this can be like an orbital effect playing around with the free energy. Um, Again, do the equation, and you find that the smaller mass is going to be moving faster, but that's only in terms of the actual inversion of the actual orbital, because if the smaller mass is moving faster, it has to be orbiting around the bigger mass. It has to be using the bigger mass's energy. So really, it looks like the bigger mass is is using up the energy, but it's actually being given to the smaller mass through Gibbs free energy and the temperature, and that would be because of a spin. And I don't think I have anything more than that. I don't know if that's what I wanted to say, but yeah. All right. I just also wanted to quickly add in terms of the train and see if I can uh, see if there's going to be any progress with just the trains. So I'll have um, I'll have the smaller train colliding uh, into the bigger train. Uh, the bigger train receiving what is it? The one, the two, uh, one has um one half mv squared, the velocity squared, half the mass, half the mass. All right, so these velocities are sharing, or these masses are sharing the same velocity. One is smaller, and inversely, the bigger mass is going to move slower, and the smaller mass is going to uh, have a higher energy. And in terms of these trains and their collision, I would say that again, you can do it in terms. I mean, you can see it like in terms of a lever, or like you can see it in terms of the fulcrum and them going around like a AC uh, like a AC unit or whatever the hell those Tesla things are. I don't know anything about generators, AC generator. I mean, I can't quite put the magnetism into this, but again, you can see that if the smaller mass is repelling uh, with a higher velocity than the bigger mass, when their outcomes are split and they have uh, equal opportunity, let's say in the universe, and they collide, and the smaller mass gains more velocity. Inversely, I would just argue that, well, contrary to the inverse kinetic energy effect, there was a collision. That collision uh, caused the caused the smaller mass to repel more quickly, and then the gravitational pull was the just the liner to say the spin effect to complete the spin effect in terms of the orbital. The larger mass was moving. The larger mass was in fact moving slower. It looked like the larger mass was moving. It had no movement. Uh, the smaller mass looked like it was actually firing out, but it was actually firing out at a quicker speed, except in a curvature in an orbital. And I'd say that that's how something like this Lewin paradox um, would incorporate the free energy. I mean, I really would agree that it's free energy, but I would say that would be sort of a explanation. So I think that's it.